Okay, in this tutorial we will talk about function pointers. We are inside Xcode. Let's create a new project. Let's make a command line tool and call it something like test. Okay, here is our project. Let's tidy up a bit. Our main function is here. So, and our code goes here. So, suppose that we have a function that we want to call from the main function. So let's have a function. We shall take a function which returns an int. We'll call it add. It takes two parameters, an int called n and then int called m. Okay, and let's define that also. Return n plus m. Here is our function. Now, if we call that function, for instance, int c equals add 3, 4 and print out that value like this, run, we see that the value printed out is 7, and it is exactly what we expect. Now suppose that we want to have a function pointer to this function and use the function pointer instead of calling the function directly. Well, in that case, we should be aware of the type of the functions. Well, what do I mean with the type? Well, if we write something like int num, then the num is a variable and the type of the num is int. In the case of the function, the name of the function is add, but what is the type? Well, the type is actually int as output and int as the arguments. So we could say that int and int is the type of the function add. Now, if we had used a similar syntax as here, putting the name after the type, we could have declared the function like this. But that convention is not used in C. Instead, we take this and we put it inside, we wrap it up in the middle of the type. And that's what you got here. But the important thing to notice here is that this is the type of our function. So let's declare a function with the type int and arguments int and int. So this type will be the same as the type of the add function. And let's create a pointer that points to it. And this is a pointer, and we're calling it something like func pointer. So now we have declared a pointer that can point to add, and we can now give our func pointer a value, which is the address of the add function. Now we have that. So instead of calling add, we can call func pointer. Like this. Oops. Func pointer. If you substitute ampersand add in here, the star and the ampersand will take each other out, and it will only stand add 3, 4, which should give the same result as before. Well, to see that it changes, let's say this is 7, and this should give the value of 10. Let's run and test. And as you can see, it works. Now we have first declared the type, and then we have used function. But we could also have combined these two, just like we do for variables. Instead of writing int num and then num equals 3, we normally write int num equals 3 like this. And similarly, we can do for our function, like taking both type and name, putting it equal to add. So this should work as well. So let's test it. And as you can see, it works. Let's change this. So we see that the value change, and you can see it works. Okay, let's go back to the previous syntax, because it was easier to read. Like this. Let's see that it works. Yes. Okay. You see this ampersand. It sets the address of the function add. Now compiler knows that this is a function. It can see it from declaration. So if it sees just add, it knows that when you write it like this, that it is an address which is meant by this side. So the ampersand is optional, and we can test that it works without ampersand as well. And also this store func pointer. Each time you apply a star to a function pointer, you produce an expression that compiler immediately decays back to function pointer itself. So this star is also optional. We can see that it works without it. Like this. However, here in the declaration of the type, here the star is necessary. Here the star is needed. So we cannot take away this star. It wouldn't compile. So what do we use function pointers for? Well, here we are using our function pointer to point to add. But let's suppose that we have another function which has the same type, that is accepting two ints and producing one int. Let's call it mult this time. Return n times m. And instead of having this add, let's put a mult. So we take mult, so let's take 5 and 7 there, and 5 and 7 here. Let's change this to D. Now, let's do it like this. Here we are printing C, and here we are printing D. Okay, let's run this. And as you can see, the first is 12 and the second is 35. So you can switch what function pointer points to dynamically, and that is one use of function pointers. But that is not the only use. You can also use function pointers as parameters to function, and also as return values of functions. Let's see how that is done. First, we will take away this. And now we will declare a function that takes a function pointer as parameter. This will produce an integer, the name of the function square root, and it will accept a function pointer. A function pointer of the same type as we have here. So let's paste that in. We can call it whatever we want here. Let's call it f pointer. And the contents of our function, the definition of the function, will be that we give the value of f pointer, let's say 2 and 6. Now I will be 12, and then we return, no, not square root, square. We return I multiplied by I. Okay, so if we have 12 here in I, this will return, now I will be 8, and this will return 64. Okay. So here we have another function, the square function, which accepts a function pointer of type int as output and int as input. So we have a function pointer which we point to add function, and then our C we will call the square function, and the square function will have func pointer as in parameter. So if this is all correct, this will print out 64. So let's test it. Something is missing. Yeah. 64. So we see that we can send function pointers as parameters. So if you look at this syntax, it seems rather complicated and it is easy to make mistakes. But there is one trick we can use to simplify it, and that is to use the type definition. So we can declare a type for our function. Type def, and the type is returning int and accepting 2 ints. And then we have to have a name for our type, and the name will be a pointer to a function, and we can call this function pointer, for instance, my func definition or something like that. We need a name in order to refer to it when we use the type. So this is the name of the type for our function. So now that we have this, we can simply declare, instead of this cumbersome syntax, we can just say my funcdef and then the name of the function. So f pointer is a pointer of type my funcdef. See if this works. 64, let's change. Now we expect 100 and it works. Now we have also used this here, which is exactly this type. So we could just declare our function pointer as my funcdef and take away this. Let's run that one more time, and you see it works. So now it looks nicer, because now you have the type in front of the name, and the syntax looks just like for normal variables, although we are dealing with functions here. So there is everything for this tutorial. Thank you for watching.